Good afternoon. In today's session, we have to study about the braking in DC motor. We will wait for other students for 1 minute. So we can start our today's session. We know about DC machine. DC machine means what? We are saying it is like a electromechanical converter. It means what? We can convert electrical energy into a mechanical, or we can do vice versa. Then we have studied about there are two types of DC machines, DC motor and the DC generator. DC motor means what? The type of DC machine which will uses electrical energy and which will convert that electrical energy into a mechanical work. That can be in the form of light, that can be in the form of heat, any form. It means what? It is converting EMF into another form. Then we have studied about the DC generator. We have seen in DC generator, it will take the mechanical energy and it will give us electrical energy. Then we have seen the constructions for DC motor and the DC generator. DC motor, DC generator, both are having the same construction diagram, both are having same general construction because both are having pole and yoke as a stator, which will not rotate, which will remain stationary part. And if you see the armature winding, commutator, brushes, these are the rotor of the DC machines, which will rotate when we will give the power supply. Then we have seen about the EMF, generated EMF and the back EMF in the DC motor. Because we are calling EMF as a back EMF in the DC motor because it will work opposite phase with respect to the supply voltage. And it is very much necessary because if we are not considering back EMF at that time, there will be no amount of power will left to do mechanical work. That's why there is a need of back EMF. Then we have seen about torque equations, the mechanical power, which is nothing but it is the product of torque and the angular frequency. Abhishek, please mute yourself. Rahul. Rahul, I'm muting again. You are okay. Huh? So, then we have studied about the different types of load at the output of DC machines. This can be domestic, this can be agriculture, this can be industrial. Then we have studied about the different types of the DC motor like self-excited and the separately. It means what? If we are giving separate power supply to the DC motor and to the field winding. And DC motor, we are saying it is nothing but the armature because it will work as a conductor. Then we have seen about the DC shunt motor. We have seen the working of DC shunt motor because we are saying that DC motor as a DC shunt. If you see the construction for the DC shunt motor at that time, you will realize the field winding is in the shunt with respect to the armature winding. That's why we are calling that type of motor as the DC shunt motor. Then we have seen about the dynamics of load with respect to DC motor. Then we have seen about in last session, we have seen about how to reverse the direction of DC motor. If we are supposed to reverse the direction of motor, we can reverse only by changing the polarities of power supply. It means what? When we are giving the power supply to the DC motor, at that time, if we are making inverse power supply, it means what? Polarity we are changing. We are taking positive as negative and negative as positive. It means what? If we are changing the direction of power supply, at that time, the electrical current will get reversed. मतलब वो करंट का डायरेक्शन चेंज हो जाएगा and as the direction of current will get reversed, the rotation of DC motor will get reversed. Or there is another one method. We can change the direction of magnetic field because we know when we are supposed to study about the reversal of direction of rotation of DC motor, at that time we are using the Fleming left hand rule, and Fleming left hand rule states that if our first finger which is downward directions, and it will represent the direction of magnetic field. At that time, our second finger, which will perpendicular to that our first finger, which will towards the computer screen, it will represent the direction of current, and our thumb will be perpendicular to that, and it will be to the LHS, left hand side. So if we are supposed to reverse the direction of DC motor, at that time, if we are changing the direction of magnetic field, how we can change? If we are changing this polarity, ये positive की जगह if we are changing here negative and here we are taking the positive, at that time you can see here, if we are changing the direction of magnetic field, how we can change? If it is going in forward direction, in upward direction, if we are taking in the downward direction, it means what? We are reversing the direction of magnetic field, or we can change the direction of this force, this current. So in that way we can reverse the direction of rotation of DC motor. But if we are changing the direction of magnetic field and we are changing the direction of current passing through the conductor at a time, if both directions are reversed, at that time the direction of force experience the same value. What will happen? It will experience the same value and there will no get reverse direction of rotation of DC motor. So in today's session, we can see about the braking in DC motor. Braking means what? We can say in the electrical and electronics engineering, braking as a electrical braking, because these things we are supposed to study in the DC machines, DC motor. If any motor is in running condition, and suppose we are supposed to make that running condition directly into a stop position, at that time we can use electrical braking concept. So here, if running motor we are supposed to brought to rest position quickly, suddenly, by giving the electrical braking concept, at that time we can say we can use the electrical braking concept. We can stop that running position except inconvenient to other. It means what? We can give electrical brake and we will make that running device into a stop condition. So we can say about the electrical braking, like electrical braking is usually employed in applications to stop unit driven by motors in exact position. It means what? It will allow us to stop that driven motor which will not harm anyone, which will not release their speed. It will directly, suitably control during the deceleration phase. So by using the electrical braking, we can make accurate emergency frequent stop without harming the passenger. So we can say about the electrical braking, like it will allow us smooth stops without any inconvenience to the passengers. And when a loaded hoist is lowered, at that time electrical braking keeps the speed that will be in the safe limit. Because if we are not making that speed less, we can make some dangerous, we will, so we are supposed to use the electrical braking, but which will keep the speed in the safe limit, otherwise the machine will reach the dangerous value. Because we are giving the electrical brake to the running motor, that's why we are supposed to keep that speed in the safe limit. So here, if a train goes down a steep gradient, it means what? If there is a gradient, if there is any slope, at that time we can apply electrical braking to hold that train speed within the prescribed safe limit. Like when we are driving our two-wheeler, four-wheeler, at that time, if there is any slope, At that time, what we are doing, we are making our speed less. In that way, if there is any electrical train which is going down a steep gradient, at that time we can apply electrical braking to hold that train speed within the prescribed safe limit. So electrical braking is morely commonly used nowadays, where we will be needed the active loads. So we can see about the electrical braking, like the braking force can also obtained by using the mechanical brakes. So here if you see, there are some disadvantages of the mechanical brake, because when we are giving the brake, we will require larger amount of power, and that will be wasted in the form of heat, because when we are supposed to apply electrical brake, at that time we are making the running device to a frequent stop condition. That's why there will be braking power which will be wasted in the form of heat. And if you see, it will require frequent maintenance and replacement of the brake shoes. We are supposed to replace that shoes very frequently. If you see, there are different types of electrical braking, like regenerative braking, dynamic or rheostat braking, plugging or reverse current braking. So we can see how to give regenerative brake in the DC motor. So we are aware about the DC shunt motor, because in our syllabus we are supposed to study about DC shunt motor. That's why in any parameter we are using this motor only. So here we can see, if our field winding is in parallel with the armature winding, just wait for a minute, I call. What we are saying here, if field winding is in parallel with the armature winding, at that time we are saying this motor as a DC shunt motor, and we are aware about how to apply KVL, how we will get the equations for back EMF. So here, when we are supposed to use the regenerative braking in the DC shunt motor, at that time the power or energy of driven machinery, which is kinetic energy, because when that motor will be in the rotating condition, at that time we will we can see here, we will get that energy in the form of kinetic energy. So we can say in regenerative braking, the energy which is in the form of kinetic is returned back to the power supply. And a machine which is operating as DC motor, it will go to the regenerative braking if its speed becomes sufficiently high, so as to make back EMF greater than supply voltage. We are aware about the equations for voltage. When we are supposed to calculate the equations for voltage for these DC machines, we can calculate like EMF across this armature winding and the voltage because of this armature. So you will armature resistance. So you will get that voltage as IaRa. So you can take V equal to back EMF plus IaRa. So you will get equations like EB equal to V minus IaRa. But when we are supposed to give the electrical braking, at that time, what we are saying, we will be needed the back EMF that will be greater than the supply voltage. जो बैक ईएमएफ जनरेट हो रहा है उसका वैल्यू जो हम वोल्टेज यहाँ दे रहे हैं उसकी कंपैरिजन में ज़्यादा चाहिए. So how we can make here? So obviously under these conditions, if the directions of armature current will reverse, if we are changing the direction of IA, you will get here. If you see here, if we are reversing, what will happen? Minus हो जाएगा फिर से, minus minus plus, so your EB value will become higher. So here we can say, to increase the value of EB, just wait, संकेत को ऑडियो नहीं ज्वाइन. आई कांट हियर यू। जो ऑडियो ही नहीं ज्वाइन किया तो आवाज कैसे आएगी? ओके, बाकी सबको आवाज आ रही है ना अच्छी से?
Yes, ma'am.
हाँ, ओके। हाँ, so I have drop message to him, he will catch us. Okay, so you can see here, when we are supposed to increase the value of back EMF as compared to the supply voltage, you can see here we are getting the equations of back EMF in the form of supply voltage and the armature current and the armature resistance. So here, when we are supposed to increase the back EMF, if we are reversing the direction of IA, we will get the higher amount of back EMF. So in that way, we can say, obviously under these conditions, if we are changing the direction of armature current, we will get the torque which is opposite to the direction of rotation of torque. And we are aware about the torque and armature current. Already we have seen speed characteristics. The characteristics of DC shunt motor, torque and speed ka, torque and armature current. We have already seen this. In that way, what we are saying, the value of torque is directly proportional to the Ia with phi. So here, if we are reversing the direction of armature current, obviously it will reverse the direction of torque. Okay, so here what we are saying here, if we are supposed to increase the value of back EMF, which will be required greater than the supply voltage to go our DC motor to the regenerative braking, we can reverse the direction of armature current, and as we are reversing the direction of armature current, the value of torque will get reverse bias, reverse directions, because we are aware about torque is directly proportional to the armature current. So here, if we are having the circuit DC machines in practical, what we can say here, if you see here, if we are, this is the circuit diagram A and this is the circuit diagram B. So what we are saying here, if we are having the circuit, the normal motor operation is shown in the figure. How it will happen? If we are giving here power supply, this is nothing but the DC machines. And here we are taking the field winding. IF is nothing but field current. We are taking it is in parallel, the same diagram. सिर्फ यहाँ पे फील्ड लिया है और डीसी मोटर यहाँ पे लिया है, the same diagram we are taking. But when practically we are supposed to use the regenerative braking concept, at that time you can see here, if we are having any electrical machines and we are supposed to use the regenerative braking, at that time in the normal motor DC operations, we will get the value of armature current, which we are drawing like we will get value of supply voltage greater than EB. But what we are saying, when we are supposed to use the regenerative braking concept, at that time we will be needed EB greater than V. बट नॉर्मल ऑपरेशन में क्या होता है कि बैक ईएमएफ का वैल्यू सप्लाई वोल्टेज से कम होता है, एंड इफ यू सी इट विल बी इन द ऑपोजिट डायरेक्शन विद द सप्लाई वोल्टेज. But here we are aware about the equation for the back EMF in the form of number of pole, in the form of speed, in the form of magnetic flux, in the form of cross-sectional area for that parallel path of the field winding. So we will get EB equal to N1. So this is the speed which will be measured in the rotation per minute, because rotation per second को हम capital N ले रहे हैं. So here we are taking that speed as rotation per minute, per second. Small n is for per second. So if we are having these equations, and again if you are writing in the form of constant term, EB equal to K into N1 phi, we are taking K is nothing but equal to P into Z upon 60A. If we are taking this, we have seen this concept already. ये equations हम पढ़ चुके हैं. But what we are supposed to see here, we are supposed to see how to use regenerative braking. So in normal operations, we are saying the value of back EMF is smaller as compared to the supply voltage. So question is how we are supposed to speed on its won't become large enough to make our EB small as compared to V, which will cause regenerative braking. So such situation will occur in practical when the mechanical load itself will become active. So here, if we are having this circuit A and B, ये यहाँ पे what we are saying, if we are explaining that situation in these figures, machine which is operating as motor, and if machine which is operating by using the regenerative braking, if we are not operating machine as regenerative, if we are only operating machine as a motor, at that time what we can say, there will be no gradient, without gradient. But if there is any slope, at that time we are making speed less, and we are supposed to increase the back EMF, that will be greater than V. But if there will be no regenerative concept, at that time we have seen we will get the value of back EMF that will be less than supply voltage. So here, imagine if any DC motor which is coupled to the wheel of locomotive which is moving. Electric locomotive is nothing but one type of electromechanical converter. It will move along a plane or a straight track without any gradient. At that time, we can say our DC machine is running as a DC motor because there will be no gradient. But if, however, when there is a track and that slope will be downward, as shown in this figure B. So what we are saying here, the component of gravitational force along the track also appears, which will try to accelerate the motor and which will increase the speed. So you will get here our equations which will increase, which will reverse the direction of current, and you will get the value of back EMF that will be greater than V, greater than V. So in such case, we can say we can reverse the direction of armature current by feeding power supply back. So here, when we are having the track which is downward gradient, at that time component of gravitational force along the track also appears, which will try to accelerate the motor and which will make increase its speed to the N2, such that we will get the value of back EMF that will be equal to K into phi into N2. ये यही equations we are taking. But what we are saying, N1, N2, because this is the EMF for the machine which will operate as a motor when there is no gradient. But if there is gradient, at that time when we are measuring the speed, at that time we are saying that speed as a N2. That's why we can take, we will get the value of back EMF will be equal to K into phi into N2, and it will be now greater than supply voltage. So here we can see we can reverse the direction of IA, and as we are reversing the direction of IA, we will get regenerative braking in the DC machines. So here regenerative braking will not stop the motor, but it will help to arrest the rise of dangerously high speed. इट मीन्स व्हाट, हम उसको डायरेक्टली स्टॉप तो नहीं कर सकते हैं, बट जो डेंजरस, जो उसका स्पीड ज्यादा था, इट विल allow that speed to come into a safe mode. So it will help to arrest that rising speed to come into a safe limit. So here we can see some applications for regenerative braking, because the necessity condition for regeneration is nothing but we will require the value of back EMF that will be greater than the supply voltage, and for that we are supposed to reverse the direction of armature current, and the mode of operation will changes from motoring to generating. It means what, we are saying there is a two type of DC machines, electromechanical converter, matlab DC machine or the DC DC motor or a DC generator. So we can say when we are supposed to use the regeneration braking in the DC shunt motor, there is a necessity condition like we will be required the value of back EMF that would be greater than supply voltage. Second condition will be we are supposed to reverse the direction of armature current, and our third condition will be the mode of operation will changes from DC motoring to DC generating. So here, if you see, there are some applications for regenerative braking. We can use regenerative braking where there is a gradient, and where we will be needed the frequent braking, where will be needed the slowing of drivers is required. Again, if you see, it is most useful in the holding a descending load of high potential energy at a constant speed. So regenerative braking is used to control the speed of DC motors where driving loads such as in electrical locomotives, in the elevators, in the cranes, hoist, we can use the regenerative braking. So regenerative braking cannot be used for stopping the motor, but it will allow us to control the speed, which will not above the no load speed of the DC motor driving, and regenerative braking will convert dangerous speed into a safe speed mode. So here we have finished our third unit, that is nothing but the DC machines. We have studied already about DC motor, DC generator, constructions of DC motor, DC generator, EMF equation, torque equation, speed torque characteristics, DC shunt motor, then load across the DC motor, dynamics of load, how to reverse the direction of DC motor, and regenerative braking concept in the DC machines. So I will I will send today for assignment, and also for uh, all notes, all PPTs for this unit. You guys are supposed to submit the assignment before Saturday, and there will be unit test on coming Thursday for third unit. There will be MCQ questions, 15 questions, same format. Uh, that paper will be for 30 marks. If anyone is facing any issue, you can ask me. I'm taking your attendance. Okay.
Hello, ma'am.
Huh? You can ask.
Ma'am, that assignment we will write in a book and then make a PDF and send it to you on classroom.
कैसे भी चलेगा, तुम नोटबुक पे लिख के उसकी इमेज मतलब फोटो को पीडीएफ में कन्वर्ट करके वैसे भेज सकते हो, और यू कैन राइट ऑन द वर्ड एंड यू कैन सेंड
Okay.
पीडीएफ फाइल, एनी मेथड you can use, because
Okay,
there are
ma'am.
lots of questions on theory only. There is only two three questions on numericals, because only in this unit remaining Arduino and all these things there will be the programming, so you can write in word also.
Okay.
Okay, as per your convenience you can write. Huh.
Ma'am, when is the college starting?
uh, I don't have that much idea because हाँ कोरोना मतलब अभी कुछ हो ही नहीं रहा है ना, तो नहीं पता है, मतलब अभी कुछ
Hmm.
आया नहीं है करिकुलम.
Okay.
If I will get the things, I will tell you. We'll come back to you. Okay. Or there anyone, if anyone is facing any issue, you can ask me. We are having the 5 minutes. Okay, thank you.